have two other angles. Usually to use trigonometry, or there is formulas that are important, which are the Pythagorean theorem, and you have the trig ratios, okay? And these are two things that you can only use for right angle triangles. Okay? Do you guys remember what the formula for Pythagorean theorem is? That's right. So this is where Pythagorean figured that if I add the square of the bases or of the legs of a right angle triangle, so where you have the two legs, the legs that form the 90 degree, if I add the square of that, they're going to equal to the square of the hypotenuse. So this is your hypotenuse. Okay, it's called letter C. Hypotenuse is the longest side of your triangle. Okay, and it's always the one that's across from the 90 degree. Okay, so Pythagorean theorem came up with this theorem that, and it does work every single time. So whenever you add the square of the legs, it's going to equal to c squared. Okay? So in this case, if you know two of the sides, no matter which sides you know, if you know A and C, or if you know A and B, or if you know B and C, you can find the third side by using this. Okay? So let's say if I know B and C, okay, I can find A. What do I do? So A squared equal to what? So if I bring this over, what does it become? C squared minus B squared. Okay? If I know A and C and I'm looking for B, what do I do? So it's C squared minus A squared. Okay? So as long as I know two sides, I can find the third by using one of these three formulas. At the end, whenever you're done, you just square root to find the actual value. Okay? So let's look at an example. So if I have I know it's a right angle triangle. I know A. And I know, what do we call this? C, that's your hypotenuse. Right? I know A and I know C. I'm looking for B. So, I'm looking for B, so the formula is going to be B squared equals to C squared minus A squared. Do you guys have any questions about this? Okay? Remember that I can start with my original formula and I can isolate for B squared. By bringing A squared over, it becomes minus. This is where algebra is coming. Plug in my numbers. So C is 5. So that's 5 squared minus 4 squared. 5 squared, that's 25. Minus 16, so that is 9. So B squared is 9. I need to find B, right? So to find B, I just have to square root both sides, and that tells me that B equals to 3. Okay? So I use Pythagorean theorem to solve for the third side, knowing two sides. Do you guys remember this now? Now, other than the Pythagorean theorem, in the right angle triangle, I can use trig ratios. So the trig ratios that we cover in college levels are the sine, cosine, and tan. So these are the 3 trig ratios. Okay? So, do you guys remember? Okay. So if you remember, SO stands for sine theta equals to, O is opposite over hypotenuse. Cosine is adjacent over I love this one. Over hypotenuse. And then tan is opposite over adjacent. Now, how can I know which one's the opposite, which one's the adjacent, which one's the hypotenuse? And this is where naming your triangle is very, very important. Okay? So again, I have a right angle triangle. This is my right angle. In this case, you must either have an angle or you must be looking for an angle. Okay? Because you need to have an angle of interest or an angle of focus. Okay? 90 degree cannot be your angle of focus. So let's say in this case, I am given this angle right here. This is given to me. Okay? So now we call this our angle of focus. Okay? Now if I want to name the triangle, there's one side that will never change, which is the hypotenuse. Where is the hypotenuse? The longest side, which is the one across from the 90 degree, right? This is never going to change. Now the two other things that I need to know is adjacent and opposite. These will change depending on where is your angle of focus. Is it here at the bottom or is it here at the top? Okay? Now this is where my angle of focus is. Now looking at this angle, what side is opposite to this angle? The vertical one right here, right? So this is opposite to this angle. And then that leaves this to be the adjacent because this shares, adjacent means it's near, right? So you have opposite and you have adjacent. Okay? So then you can decide which one to use according to which sides are given to you. Okay? So let's say if they give you the opposite and the hypotenuse, then you have to use sine. If they give you the adjacent and the opposite, you have to use tan. Then it depends on what is given to you or what you're looking for. Things change if they give you this angle, for example, or if you're looking for this angle, right? If you're looking for this angle, then where's your opposite now? Right here. And where's your adjacent? Right here. The hypotenuse doesn't change. Okay? But naming the other sides depends on where is your angle of focus or angle of interest. Does that make sense? So let's look at an example. I'm just going to use the sides that we got up there. So I'm going to use this as 4 and this as 3 and this as 5. Actually, I'm just going to give you these two. And I want you to look for this angle. So we're going to call this A, B, C. And then this is angle theta. And I want you to look for angle B. So the question is asking you to solve for angle B. first thing you want to do, you know it's a right angle triangle, you want to name your sides according to angle B. According to angle B, where is the opposite, where is the adjacent, where is the hypotenuse? 3 is the opposite, 4 is the adjacent, and this one is the hypotenuse. Okay? Now the question comes, how can I solve angle B? What sides do I know? The opposite and the adjacent. So this is where you're gonna come and say, okay, Sokato, where are you? I know O and A. So which one do I use? Tan. So this is where I'm gonna say, okay, tan theta equals to O over A. Okay? My opposite is 3, and my adjacent is 4. Okay? So I set up my question. I put everything where it's supposed to be, but the question is solve for your angle. Haven't solved for it yet. Okay? To solve for the angle, who remembers what I need to do? Because if I do tan theta equals to 3 over 4 is 0.75. So if I do this, that's going to be tan theta equals 0.75. And I'm sure that your angle theta is not 0.75.
Is this when you punch it into the calculator?
Do what? Tan inverse. Look at your calculators. On top of this sine, cosine, and tan, there is the sine to the power of -1, or the tan to the power of -1, or the cos to the power of -1. See that? So this is where you're going to have to press your second shift or whatever shift button that you have, okay, to reach that. So anytime I'm looking for the angle, I'm going to have to perform the inverse function, which we call tan inverse, in this case, of 0.75. So it's a matter of literally taking your calculator, pressing second or shift, tan 0.75. Unless your calculator is backward, you have to put 0.75 first. And do that on the calculator, tell me what you guess. What do you get? You have to do units backward. What is it? 36.8. So if I'm looking at degrees, it has to be 37. Because technically angles, we don't measure them to decimals. We have to keep our angles to the nearest degree. So since your answer is 36.8 degrees, so that's 37 degrees. You round it up. Okay? So what I know here, I know two sides. I was able to solve for the angle using the primary trigonometric ratio, okay, or the trig ratios. Are you okay with that? Now my question to you, can you tell me what would be angle A? What would be the measure of angle A? So you know, what's the measure of all the angles inside a triangle when I add them all up? What is it always? 180, right? So I know that if I add A plus B plus C as angles, they're going to add up to 180. I know that this is 90, and I know that this is 37, right? So in order for me to find angle A, it's as simple as just doing 180 minus 90 minus 37. Yes? Can I do, is that 53? Yeah? Now, can I use maybe use it this way and then make this opposite, make this adjacent and use tan? Yes, you can. Is it getting you the same answer? Yes, it will. Which one is easier? To do all of this again, or to do this? It's this, right? Obvious. Okay? So when it comes to the trigonometry, and especially when it comes to the right angle triangle, it's about knowing what formula to use. You only have 4 options. Pythagorean theorem, and then one of these 3, sine, cosine, or tan. Now, what if I am given this? What are you giving this? I'll give you that back, Katie. And I'm asking you to solve for the hypotenuse. What's the first thing you want to do? Assign your sides, right? So what are my sides? Where's my opposite? Where's my adjacent? Where's my hypotenuse?
Your opposite is across from the angle.
So that's your opposite here? Okay. That's your adjacent, and that's your hypotenuse. What do you know? What are you looking for? Looking for the hypotenuse, you know the opposite. So because I'm looking at SOHCAHTOA, so the 2 things that I'm interested in, basically, the opposite and the hypotenuse. So which one? Sine, right? Because that's the one that has the opposite and the hypotenuse in it. So in this case, I'm going to use sine. Do I know the angle? That's where it's going to be, replace the 40 degrees. So it's going to be sine 40 equals, do I know the opposite? 2 over whatever this is, x. So my question to you, how do you solve for that hypotenuse? So if I cross multiply, that hypotenuse will come up here, right? So it becomes hypotenuse times sine 40 equals to 2. Then what do I have to do? What's happening between the hypotenuse and the sine 40? What kind of operation do I have here? What did I just do here? So I multiplied, right? If I want to bring the sine 40 over, what does it become? Instead of multiplication. So it's going to be the hypotenuse is 2 over sine 40. Right? So what I say, when you're looking for the denominator, all what you have to do is actually switch spots. The sine 40 will come down, the hypotenuse So what's 2 divided by sine 40?